Hello all, welcome back to this video on n-queens problem. Imagine you're having a chessboard. Now imagine trying to place n queens on it so that no two queens attack each other. That's the challenge posed by n-queens problem. So going into the definition, the n-queen problem asks how can you place n queens on n by n chessboard so that no two queens attack each other. They should not attack each other either horizontally or vertically or diagonally. Okay, so in detail, what is n queens problem? How can you place n queens on n by n chessboard so that no two queens can attack each other? Queens should not be attacked either horizontally or vertically or diagonally. So our task is to place them in a way that no two queens are in the same row, same column or on the diagonal. Okay. Imagine you are having four queens. You are having four queens and you need to place them in 4 by 4 chessboard. 1, 2, 3 and 4. 1, 2, 3 and 4. So first queen Q1 I'll be placing here, Q1, and again Q2 I cannot place it in the same column or in the same row, or it should not be placed in the diagonally, either diagonally, so it cannot be attacked. So I'll place Q2 here, and again coming to Q3 I cannot place in the same column or in the same in the same row or in the same column, or cannot place it in on the diagonal. So I'll go for Q3 here, and again coming to Q4, not in the same line, not in the same column, nor on the diagonal. So I am left with only this position, that is Q4. This is how n-queen problem is performed. Okay. So why is the problem so interesting? It is a classic constraint satisfaction problem, meaning you are trying to meet specific rules while making decisions. So what are we doing here? We are trying to meet specific rules while making decisions. Okay. So while we are making decisions, we are following specific rules. So as n increases, as the number of queens increases, the number of arrangements grows exponentially. So the problem grows exponentially harder as n increases. Okay. It is a perfect example of how backtracking can solve complex puzzles. So we are using the concept of backtracking to solve the complex puzzle. Okay. By trying, failing and trying again. What are the steps followed? Trying, failing and trying back again. Okay. This is the concept followed here. So already in the previous videos we have discussed what is backtracking. First we will take a decision, and if it is positive and the solution is optimal, then we'll commit it. If it is not the optimal solution, we'll prune it or backtrack it. Okay. Next, how backtracking solves n-queens. Backtracking is like intelligent trial and error method. So what is backtracking? It is like trial and error intelligent method. Okay. So here is how it works. Start with the first row. We'll start with the first row. Try placing a queen in each column. Okay. In each column one by one. Okay. We'll start with the first row and we'll try placing queen in each and every column one by one. For every attempted placement, check if it's safe or not. First we'll check if it is safe or not. It's not attacked by any other previously placed queens. Okay. If the position is safe, we'll move to the next row. So this works better if we go to the second row. So we'll place the queen in each and every column. We'll check whether if it is safe. For example, in the second queen, if it is placed here, no, it can be attacked by the first queen. So it is not safe here. If we place Q2 here, it will be attacked by column wise. So we cannot place here. Q2 is also not safe here. So these are all options are backtracked or pruned, and we are committing with the final option here. That's why backtracking works here. Okay, I hope you got it. So until when we'll continue this pattern? When all the n queens are placed, we'll stop the process or the pattern. If we have tried every other possible configuration. So until when this process of backtracking continues? Until when this process of backtracking continues? Till all the n queens are placed. Okay. So now what is the application and importance? It helps us to build a deep understanding recursive thinking, recursive problem solving, and constraint propagation, and also used as a teaching tool in algorithms and AIs. Okay. And even in the real world problems like scheduling, resource allocation, and logic or puzzle solving, this n-queens problem can be used. So applications and importance are up to recursive problem solving can be developed with n-queen problem along with the backtracking and constraint propagation, used as a teaching tool in algorithm and AI. So these insights can be applied in scheduling, resource allocation, and puzzle solving. Again, I will explain with the third row, that is Q3, if anybody did not understand. For example, I have placed Q1 here in the first row and Q2 here in the second row. For the Q3, how will I backtrack? Initially, I'll check this position Q3. No, it is not safe because Q2 can attack here, and Q3 if I place here, no, it is also not safe. Q2 can attack from here. If I place Q3 here, directly Q1 will attack from this position. So all these positions are ruled out or pruned, and I will go to this first position, which is the safest position. I will follow this pattern till all the 4 queens are placed and all the permutations and combinations are over. Okay. I hope it is very clear with n-queens problem. Thank you.